So if you remember from last year in geometry, we talked about 6 trigonometric functions or trig functions: sine, cosine, and tangent. Okay. And so this is, again, the review part. So if you have this right triangle, all these ratios do is describe um, the ratio of the side lengths, right? So we just pick 2. So the ratio of the opposite side of the hypotenuse is sine, and so on and so forth, as you see here. So we define an angle theta. Whatever that is, I will tell you which one is theta, okay? Or you'll be given one, always. And once that's defined, we label the triangle with these different labels. The hypotenuse is what it always is. The hypotenuse is always directly across from the right angle, okay? It never changes. Now, adjacent and opposite can change based on what theta is. But in this case, the adjacent is right next to theta, okay? It happens to be this side right here. If theta was up here, this would be the adjacent side. So this is the adjacent. Adjacent means next to. That's how you remember where it goes. It's next to the reference angle theta, okay? And then the other one that doesn't touch it at all, that's on the opposite side of the triangle, is the opposite, because we are boring. And we cannot be creative with naming things. So this is adjacent, opposite, and hypotenuse. And then we just construct these ratios by making fractions out of these side lengths like it tells us to do. Okay, so again, that is review. And then the second part I wanted to call your attention to is, remember we talked about Pythagorean theorem and reviewed it yesterday, where you can find a missing side of a right triangle. Sorry, that wasn't spreading. Now, what happens in some cases when we are only given one side? Well, sometimes we can find the other 2, but only in 2 special cases of a right triangle, and they are called the special rights. They're 30, 60, 90 degrees. Y'all probably heard this before. And then you have a 45, 45, 90. Now, if you are a formula person, I have listed the pattern formulas on the board, but I am going to show you the shortcut formulas, which people in general prefer. I do not care which one you use. I just know that some people prefer formulas, and so they are there for you. Now, so what you need to write down at this point are the shortcut formulas that I'm about to write on the board for a 30, 60, 90 triangle, okay? And we're just going to use a lot of, we're just going to write these down first, and then I'm going to talk to you about them. So from hypotenuse to leg, we multiply by root 3 over 2. To go from the short leg to the long leg, we multiply by root 3. And to go from the hypotenuse to the short side, we multiply by 1/2. Okay? So this right here is all you need to work on these special rights. You can use these by taking what you know and plugging them into this formula and solving for the unknown value. That's fine. But this is what I use, okay, because I find it to be less complicated. Okay, so when we are talking about a 30, 60, 90 triangle, the other thing I want you to notice and remember, and you can label this in our first example, I'm just talking to you now, is that because of the way the triangle is constructed, you're going to have a hypotenuse and you're going to have 2 legs, and one of them is going to be longer, and one of them is going to be shorter. Again, we are not creative here, like it is very boring. The longer leg is the long one, and the shorter leg is the short one. And so the first thing you need to do is identify which is which. Okay? Identify which one is the long leg, which one is the short leg, so that we can apply these shortcuts. Okay? So let's look at this triangle right here. First thing I'm going to do is I'm going to label this. Well, here's my hypotenuse. Here is my long leg, and here is my short leg. Hypotenuse, long, and short. Okay. And then I'm going to take a look at what I'm given in the problem. So the first thing I'm given is the long leg. And I'm going to take you through the long version of this, and then I'm going to do one with the short cuts, okay? So let's look at the formula up here. It says that long leg like long leg is equal to 1/2 times the hypotenuse times the square root of 3. Okay, do you see where I'm pulling that formula from in the right box? Okay. So if you like formulas, this is what you do. You say, okay, well, L is 8, right? Because that's the length of the long leg. So I'm just going to plug in 8 to the formula. And then I'm going to solve for H. I'm just going to divide by root 3 and 1/2, okay? So let's do that real quick. So if I take 8, I'm going to divide by root 3, and then I'm going to divide that by 2, okay? Because of course, if these are multiplied values, I'm solving for H. Division gets rid of those. Agree? All right. Let's see. So I'm going to divide by 1/2 and root 3. I'm sorry if I misspoke and said divide by 2. We don't do that. We're going to divide by 1/2. All right. Notice this is not the way I do this. So you're going to find then, if you solve for H, that H is going to be, or the hypotenuse is going to be 16 times the root of 3 over 3. Basically, my scratch work here, what I put into the calculator was, 8 divided by 1/2 times the root of 3. And then that gave me this, because I solved for H. All right, so now that we've got H, let's mark that on here. I've got 16 square root of 3 over 3. Okay, so let's find another formula that's going to relate these. It says the short leg is equal to 1/2 the hypotenuse. So let's write that. So short is equal to 1/2 hypotenuse, but I have the hypotenuse now, right? So let's plug that in there. Short is equal to 1/2 times this big ugly thing right here. And that's fine. We'll put it in our calculator. And then you'll see that this is 8 root 3 over 3. And that is the length of your short side. Okay. That is the length of your short side. So here are all of your side lengths. 8. And you have 8 root 3 and 16 root 3 over 3. That is doing it with the formulas, okay? It is achievable. It is longer. It's more drawn out. But what the shortcut rules that we wrote down do is they actually just simplify the formula work. They just make them into more manageable pieces, right? So let's do the next one with the shortcut formulas, and then you are free to decide which is your favorite, okay? So hopefully you wrote those shortcut formulas down. Next thing I want to do is I need to identify what parts of the triangle I'm dealing with. This is the hypotenuse, this is the long leg, and this is the short leg. So according to my formula thing, let's say I've got the short right now. It says short to long leg, I multiply by root 3. So let's do that. So we're going to say, okay, I've got the short leg. I'm going to multiply it by root 3, and that's going to give me the long leg. Give that a shot. Make sure you can get this worked out. You should get 6. So the long leg is 6. Okay. Short to long leg, multiply by root 3. Simple as that. All right, so now I need something that's going to give me the hypotenuse. And it says if I want to go from the hypotenuse to the short leg, I said multiply by 1/2. Well, I want to go from the short leg to the hypotenuse. I want to go backwards than what I have. So we're going to do the opposite. What's the opposite of multiplying by 1/2? Beautiful. If you want to go backwards in your shortcuts, instead of multiply, just divide. So instead, I'm just going to say, okay, I'm going to take my short leg, and I'm going to instead divide by 1/2. No worries, your calculator will do that for you. And you're going to get 4 root 3. And so you're done now. Okay. I'm going to write down here in black kind of as a sidebar. To go backwards, if you want to do S to H, you divide by 1/2, which makes sense. You go the opposite direction, so you do the opposite operation. But if you have these guys up here, you should be fine, because if we go from H to, if I have the hypotenuse and I want the long leg, I multiply by √3/2. If I want to go in the opposite direction, long to hypotenuse, I divide by √3/2. I want to go from the short to the long, multiply by √3, long to short, divide by √3. So those few little lines are all you need to navigate these with a lot less convoluted process than in this first one that we did. Okay, it works every time either way, whatever you like. Okay, that's 30, 60, 90. Let's do another type. The other type of special right triangle is an isosceles right triangle that has 45, 45, 90. Okay, and so what happens here is an isosceles triangle has two legs of the same length, right? So two of these values are the same. So the shortcut is most excellent. So for 45, 45, 90, I'm just going to skip the formulas altogether. If you like them, feel free to use them. I'm just going to give you the shortcuts for 45, 45, 90. And that is to go from any leg to the hypotenuse. You're just going to multiply by the √2. And so, of course, to go backwards, you would divide by the √2. And this is the only shortcut for 45, 45, 90 that is needed. So we're going to start with this example here. So after you write that down, you want to go ahead and sketch this triangle on your paper. And we'll do that one together. I'll give you a second now. I'm not going to write and draw a lot today. Lord have mercy. Messages. Okay, so if we are looking at this guy down here, remember, if I'm going to apply any sort of formula, shortcut, anything, I need to make sure I know what all the things are first. This is my hypotenuse, and both of these are legs. Notice there isn't a long and a short here because they're both the same. So we just both call them both leg, right? Okay, so remember what I told you a minute ago. My shortcut says leg to hypotenuse, but I'm going to have to go from hypotenuse to leg here because I'm given the hypotenuse. So according to this, I should divide by √2. I'm going to say, okay, 4 divided by √2, and that's going to give me 2√2. So if the leg here is 2√2, what's the other leg? 2√2. Yep, this is isosceles triangle. All 45, 45, 90s are going to be like that, okay? And so now we're done. I figured I would lead with the worst thing. I figured I would just lead with that. Get it out of the way. All right, so we're going to do that next example next. If you want to go ahead and see if you can tackle that one, give it a try, and then I'll throw my answers up there, and we can just kind of make sure we're on the same page. Remember, first, make sure you know what the hypotenuse is, what the legs are, and then use your shortcut. Because this time I actually did give you a leg, and you're trying to get the hypotenuse. I'm just going to rewrite our rule here. All right, so I'm going to get here. So if you're checking your answers, your hypotenuse should be 6. Both legs should be 3 root 2. And because my shortcut says to go from the leg to the hypotenuse, we multiply by root 2. So I'll say 3 root 2 times root 2, which will give me 6, and I'm done. Okay. Questions so far? 30, 60, 90, 45, 45, 90. Okay. We learned this right now, or kind of refreshed it from last time, because we are going to use it when we construct the unit circle late this week, so it's necessary. So, all right, you don't have to write all of this. All I want you to write down is this box right here. You can do that while I'm talking if you like. So again, we discussed earlier that we've already seen sine, cosine, and tangent, and that they're just ratios of these opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and you're welcome to abbreviate them with the single letters. I don't write it all the way out. And so we know sine, cosine, and tangent, and I don't know what mnemonic your teacher taught you. I do this one, so, ka, toa. I think Miss T does something else that some old hag climbed a hill.
Oh, yeah.
Yeah, so whatever it takes for you to remember it, feel free to use any tool you like. I do SOHCAHTOA just because it's easy for me to remember. And I write it like that so I can see the fractions, right, and split it apart. But that's up to you, whatever mnemonic device you choose. So again, once we know sine, cosine, and tangent, the 3 additional trigonometric functions are very easy. These are called cosecant, the CSC. The second one is called secant, and the third is called cotangent. Now, the reason they're fairly easy to remember is because they are just the reciprocals of the original 3. So cosecant is the reciprocal of sine. So instead of O over H, cosecant is H over O. Secant is the reciprocal of cosine. So instead of A over H, it's H over A. You just flip it over. Cotangent, reciprocal of tangent, A over O instead of O over A. Okay, so if you can remember those first 3 and remember which one matches up, you can easily obtain the other 3. Okay. So this is why I say it's just a very small extension of something we've already learned. You don't have to write that next blue box down. That's just there for me to introduce you some notation. We read that bottom box like this. It just says that sine of theta is the reciprocal of cosecant theta and vice versa. So cosecant's reciprocal is sine. You just flip that value over. Okay. I'm going to pause so y'all can make sure y'all got that written down. If I do and then end up going on before you're ready, it's on one note and I can scroll back up later. Okay. All right, so now we're going to apply this information. I'm going to go back. Let me back out all of this. So I give you this triangle, and I ask you to find all 6 of the trigonometric functions. That's sine, cosine, tangent, cosecant, secant, and cotangent. So the first thing I need when I'm doing this is I need all 3 sides of the triangle. Well, we have 2 ways to get those. I taught you about the special right triangles. This isn't one, but this one does have 2 things that I already know. So I'm going to use Pythagorean theorem to get that third side. So this would be, a squared plus 6 squared equals 10 squared. And you'll end up finding out that a is 8 in this case. Okay, so that's 8. So that's step 1. Find all the sides by whatever method you need to. Step number 2. This is the reference angle right here, okay? You know because it's listed as theta, and I'm asking for the value of the trig functions for theta. So the next thing we do is we're going to label the triangle appropriately with the hypotenuse, the adjacent, and the opposite. Remember that the hypotenuse is always directly across from the right angle. The adjacent is the other one that touches the reference angle. and the opposite's the one that doesn't touch the angle at all. Okay. And at this point, it's just a matter of remembering what the ratios are. So sine of theta, we'll do these three first. Cosine of theta and tangent of theta, we'll start there. So recall that sine is O over H. Looking at our diagram, O is 6, H is 10. And then we simplify that fraction. We'll end up with 3 over 5 for the value of sine. And I'm writing it out far further than you will need to, just so you can clearly see how I'm getting all my numbers. And then next, recall that cosine of theta is A over H, the adjacent over the hypotenuse. And then A is 8. Hypotenuse is 10, so that reduces to 4 over 5. And finally, tangent is O over A, or the opposite over the adjacent. But I just look up at my diagram. The O is 6, the A is 8, and so that will be 3 over 4. And so let me highlight the values for you since I'm showing my work here. The value of sine theta is 3/5, cosine theta 4/5, tangent theta 3/4. And once this part is done, since we know that the other three functions are simply the reciprocals of these, we need to remember that cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent, which actually makes sense. And these are the reciprocals. So cosecant would actually just be H over O. So I can just effectively flip this over. Secant is H over A, so I'm just going to flip that over. And then just continuing on with the same pattern. It's much easier to find the second three after you find the first three. So cosecant, secant, and cotangent. So y'all go ahead and try the next one. I'll give you a minute. I'll put my answers up. I'll make sure that you're on the same page as I am. I don't have any questions. And I think what we'll do is we'll do one with a special right triangle. And then I'm going to go ahead and let you work on your assignment after that. So I'll give you a minute to work on this one.
How do we know which one's A, B, and C? Well, I know that H is C.
Okay, so A and O correspond to A and B, right? But so the way we know that is it's based on what angle we're using as reference, which is theta in this case. Adjacent means next to. So once you've identified the hypotenuse, the other one that touches theta is the adjacent. And then the only one left is
And I'm
opposite.
talking about for the A squared plus.
Oh, it doesn't matter. These are the legs, A or B, it doesn't matter.
Okay,
And yeah, when you're working with Pythagorean theorem, these are interchangeable. Okay. Yeah, they're not specific. The legs are A and B for Pythagorean theorem. Trig, they are specific. But with Pythagorean theorem.
Thank you.
You're welcome. All right, all right, for all these. Right, just make sure you're looking up there, making sure you're getting whatever I'm getting. Ask me any questions if you need to. Remember, you should expect it to take you a minute to do this. It's a lot of detail work. It's a lot of looking, checking back. The only reason I do it so fast is because I've just been doing it for a million years. You shouldn't expect yourself to be able to do that quick yet. And these fractions don't reduce, so that's okay. All right, if you're still working on that, we can come back to it if we need to. We can finish it up. These will be here for you. Then we're going to go ahead and look at a special right triangle. Okay. You'll be asked to do several of those today in combination with this information. All right, so if I need to scroll back up to this in a little bit, that's perfectly fine. Just let me know. All right, so here is the special rights. I'll do one example of this with all the trig functions. So here's your next example. If you want to sketch it down on your paper, we're going to do this one right here, okay? So it's just a 45, 45, 90. And one of the leg lengths is 2 root 2. So I'll give y'all a minute to get that down. Okay, so first thing I want to do is, if I'm being asked to find all 6 trigonometric function values, again, the first thing my brain needs to do is think, I need all the side lengths. When I see a right triangle, the next thing my brain wants to do is use Pythagorean theorem. I can't do it. There's not enough. So then I'll realize, okay, I'm going to have to use the special rights rules. And so this is a 45, 45, 90. So my little shortcut says leg to hypotenuse, we're going to multiply by root 2. Okay, so I've got a leg, and I've got a hypotenuse. So in order to get, I know those two legs are the same in a 45, 45, 90. And in order to get the value of the hypotenuse, I just need to multiply the leg by root 2. And so you're going to find that that's 4, okay, whenever you do that. So step 1, make sure you have all of your side lengths, which we do now. Step 2 is to, if you're about to get ready to do some trig functions, you're going to have to label this triangle HOA. You got to do it. We're not given an unknown angle this time, but because I'm given an angle, I'm going to go from there. Okay, so this is my reference angle, and I'm going to label from this reference point. So this will be, again, the hypotenuse. I'm going to do these in red. This should be your adjacent side over here, and this will be your opposite side. Again, hypotenuse, the other side that touches the angle is the adjacent, and then the opposite. And we'll construct our 6 trig functions. So we'll do sine of, well, it's not theta this time, right? I know what the angle is, so that's 45 degrees. Cosine of 45 degrees, and tangent of 45 degrees. Remember, theta is just like an x if I don't know what the angle is, and I do in this case. And so again, recall that the sine of an angle is the opposite over the hypotenuse. So that's going to be 2 root 2 over 4. Cosine is the adjacent over the hypotenuse, which in this case, it actually is the exact same thing, because O and A are the same. And then finally, the tangent is the opposite over the adjacent, but that's 2 root 2 over 2 root 2, so that's just going to be 1. Right, let me write it out so we can see it and then simplify it. So this would be the opposite over the adjacent. And so when we simplify these things, we'll see that this is the square root of 2 over 2, that the cosine is the square root of 2 over 2, and that the tangent is simply 1. Okay, so there's even more like patterns in the trig functions with the special rights. So now let's go ahead and extend this to cosecant of 45 degrees, secant of 45 degrees, and tangent of 45 degrees. No, cotangent, sorry. So again, these are just the reciprocals of the originals. So this is actually going to be 2 over root 2. This will be 2 over root 2. And what's the reciprocal of 1? 1, right. So and remember also me mentioning that it's not proper to have a radical in the denominator, so we'll have to fix that. And when you do, when you punch that in there, you're going to find that that is going to be, I think, 2 root 2. Let me double check it there, if memory serves. So 2 over root 2, that's just square root of 2. So this will just be square root of 2, square root of 2. So let me highlight now. I know I've done a lot of writing up here. So the sine of 45, cosine are these values, the fully simplified ones. And then the cosecant is this, the secant is this, and the cotangent is this. Okay. So same process. We just have to do a little bit different work in order to identify the side lengths. Okay, that's all I'm going to do today. I'm going to do the last part of these notes with you tomorrow. So your assignment is in classroom. I'm only going to ask you to do numbers 1 through 18. That last section is what we will cover first thing tomorrow. But the rest of the block is just for doing that work. Need it to work. Oh, that's big of it. All right. I'm going to put it should be here. Let me update your numbers to do, but it's the 6 trig functions practice file. Let me update for a second to let y'all know that you're only doing those first few. Here you go, baby. Oh yeah, just you are welcome. Let me update that for you.